I am Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. Welcome to the lecture session of image processing. In this session, we are going to discuss about Introduction to Digital Image Processing. In this session, the contents what we are going to cover are what is digital image processing and goals of digital image processing and types of images and how to represent an image and types of digital image processing and methods used for image processing and what are the advantages and limitations in digital image processing. So let us start with the first topic. What is digital image processing? So here, this digital image processing, it is a combination of three important words like digital, image and processing. So initially, we have to talk about one of the important word which is called image. So first, what is meant by an image? Anything we see around us, visual representation of anything, we call it as an image. Generally, whenever we see the environment around us, we are going to see some images like person, trees, objects. So all those are called images and generally those images will be in 3D form. And to speak generally, image is a visual representation of anything. Coming to the next important word, that is digital. So here digital means image will be captured by a sensor and here generally image will be captured by a digital device, for example camera. That is why that particular image is called a digital image. So here the third important term is processing. The captured image will be processed by using a digital device which is called computer, digital computer. So in that computer, some efficient algorithms will be used in order to process that particular image. Operations will be performed on that particular image. So totally, this is the information about these three terms, digital image processing. So finally, digital image processing means processing digital images by means of using digital computer. And so in order to clearly understand this process, this figure will indicate how the image will be captured and how it will be processed. What are different modifications that will be done on that particular captured image. Now, so if you see here the first image and it is a green leaf which is being captured. Here this particular image will be in 3D form, that this image is captured by the environment which is around us. That's why this particular image, we call it as a 3D image. And this image is captured by a digital device which is called camera. And this captured image, it will be processed by using digital computer. And in this process, some efficient algorithms will be applied in order to perform operations on the captured image. For example, if you see this leaf image, here the main concentration is on capturing the water drop present on that leaf. So for that, in this area, sufficient related algorithm should be applied so that among that entire captured image, only the water drop of that is present on the leaf only will be generated. And this particular image generally we call as a processed image. So here the entire from the entire image only a part of the image have been enhanced. So that is the operation being performed from this digital computer. So this is the entire process of digital image processing. So here are different steps that we have applied in order to make this entire process. So first one is importing the image through image acquisition tools, which are called sensors. Here generally we can call it as a camera. And next step is analyzing and manipulating the images. So here this analyzing and manipulating the images will be done by using different sophisticated algorithms from the computer. And the last one is output. So the output can be an altered image. So this is the original image and this is the altered image we are going to get based on the algorithms what we have used in the processing, during processing. And so here we have to speak about what are different goals of digital image processing. So what is the main goal? Why we are going for digital image processing? So the first goal is enhance the quality of the images. That means the quality of the image can be improved, which is called image enhancement. So based on this concept, the quality of the image will be improved. The image will get sharpened. If so, informative, more amount of information, important information can be extracted from the image. So all these we are going to achieve from this goal. And next goal is extract the meaningful information from the images. So whatever the attributes we want, that particular attributes can be calculated from the processed image. And next one, automate image based tasks. So here different tasks can be performed on the image automatically by using digital computer, because we are going to have efficient algorithms which will be done, which will be doing the processing method. So automate image based tasks. So if the task is performed automatically on the image required task, the human intervention also will get reduced. So these are the three important goals of digital image processing. And next, we have to see what are different types of images. So generally, there are different types of images. Among different types, here there are 4 types mentioned. So first type is binary image, second type black and white image, and third one is 8-bit color format, and the fourth one is 16-bit color format. So there is a small difference between all these types of images. So coming to the first type, which is called binary image. So generally we know binary means it will be represented in terms of 0 and 1. In the same way, in this binary image representation, it contains only 2 types of pixels. So here the 2 type, we will discuss what is meant by a pixel. So here the 2 types of pixels are 0 and 1. So there is an information what pixel 0 represents and what pixel 1 represents. So here the value 0 represents, the pixel value 0 represents, it is black color, and the pixel value 1 represents, it is white in color. So that's why it is called binary image. It consists of only pixel values 0 and 1. It may be either in black color or white color. No other colors in between. No other shades in between. And next type of image is black and white image. So here the name itself says black and white. That means the image will consist of only two colors. One is black, another one is white. And the next type of image is 8-bit color format. So in this 8-bit color format, we are going to have number of bits as 8. Another name for this 8-bit color format, we can also call it as grayscale image. That particular image, another name is grayscale image. So here, in this 8-bit color format, so total number of color shades that will be available will be 256. 256 color shades will be available. So how we got the value here? 256 means as it consists of only 8 bits, it will be represented in terms of 2 power 8. So here the value of 2 power 8 is 256. That's why here 256 color shades will be available. So this value 256 will be represented from 0 to 255. So 0 represents extreme low and 255 represents extreme high. So the value present in between this 0 and 255, the middle value that is present in between this 0 to 255 is 127. That means here 127 is the middle value. So what is the extreme value 0 represents means it represents black color, and the extreme high value 255 represents means it represents white color. So the value that is present in between these two is 127. 127 value represents the color gray. And different values will be there in between these two, and in between these two, it represents different shades of different colors. And the last type of image is 16-bit color format. So here, the total number of bits will be 16. Generally, same like this. You can represent this in terms of 2 power 16, where here 16 represents the number of bits. So the value of 2 power 16 is 65, 536. So in this type of image, totally the number of shades will be high compared to 8-bit color format. So the total number of shades in 16-bit color format will be 65,536 different shades of colors will be available. So these are some of different types of images. And next we will see how to represent an image. So here generally whatever the image we see around us will be in the form of 3D. But if you capture by using any digital device, then it will be converted into 2D. So here any image is defined as a two-dimensional function. We are going to represent that 2D image in terms of f of x comma y. So here there are two important terms x and y. So here this x and y values are called spatial coordinates. These x and y values are called spatial coordinates, whereas here the value of f represents intensity or gray level of that particular spatial coordinates. Now, so here what is meant by digital device? Digital image. In any digital image, the value of this x comma y will not be same. Now, here you can see three values x, y and also f. X and y are spatial coordinates, and the value of f represents the intensity or gray level of that particular image. So, If the values of these three, x, y, and f, are all finite and discrete quantities, then we call that particular image as a digital image. So, for example, here are the two images. So, here we can see the image of a girl. Both the images are similar, but you can consider this image, we can look this image in different ways. For example, if you start looking this image considering these two values x and y, so this is called x plane and this is called y plane. So if you start looking from here at x axis and from here to y axis, so here consider this is x naught and y naught, and here both the axes are meeting at this point. Okay, so this point is called f of x naught comma y naught. So this x naught and y naught are the spatial coordinates, whereas here the value of f represents the intensity or gray level value of that particular point. And similarly, here is the same image, but if you start seeing the image from x-axis direction from here and y-axis direction from here, then these two are intersecting at this point. So this point can be represented as f of x1 comma y1. Here also x1 and y1 are the spatial coordinates at this point of the image, and f represents the intensity or gray level at this particular point. Both are same, but we have taken the difference here considering the pixel value in both the images will be different. Now, so this particular image during processing, it will be converted into digital. So digital image is composed of, as we have seen, finite number of elements, and each element has a particular location and value. So in the previous slide, we have seen two figures. If you consider, both the pixel values are not same. So finite number of elements will be there, but each pixel will be having its own value. Now, so if you consider this image, and if you are going to convert this image into digital way, and if you are concentrating at this point, so the pixel present here, which is available here. So this point generally we call as f of x comma y, and this is called pixel. Generally, all the finite elements. So if you see here, this is the entire image have been converted like this, and each will be converted into pixel, and each pixel will be having its own value, and all the pixels here will be finite in number. And these elements generally we call it as picture elements or image elements or pels or pixels. But most probably the term what we are going to use is pixel. And coming to the electromagnetic spectrum. So here vision is the basic sensor for any human being. So for the human being, vision is the advanced sense. That means we can see any images with our eyes. But for the human vision, there is a limitation. From the electromagnetic spectrum, we will be having the electromagnetic spectrum categorized. Each one will be having its own wavelength. So the electromagnetic spectrum starting from gamma rays to radio waves. But here, the human vision is limited to only this visual spectrum band. So this spectrum band will be starting from red color to violet. That means the human, if they are capable of seeing any images it is possible only if it is in the range of, if the wavelength is in the range of visual spectrum. But here, if you take computers, that is machines which are going to process the images, they are capable to have sensing from the basic band to the maximum band which is available in the electromagnetic spectrum. That means it is capable of processing the entire electromagnetic spectrum band, that is from gamma rays to radio waves. So human is limited to visual band, whereas machines can cover the entire electromagnetic spectrum. That's why we are going to use computers in order to process any type of images. Now, coming to types of digital image processing, there are 3 levels of digital image processing. So here we can see low level processing, mid level processing, and the last one is high level processing. So these 3 types differs based on the input and output. So for example, in the low level processing, if you see the low level processing, what will be the input and what will be the output. Similarly, if it is mid level processing, what will be the input and what will be the output. And the third one is high level processing. So for this high level processing also, the difference is for this type of processing to the machine, what should be the input and what should be the output. So coming to the first type, that is low level processing. In the low level processing, input will be image and output also will be image. So here in the low level processing, input will be image and output also will be image. That means, for example, to that machine, if you are giving any image where its quality is very poor or somewhat blurred, and if it is processed by using this low level processing, again you are going to get output as an image, but that particular image will be enhanced. The quality of the given image will be improved. So some of the examples that comes under this low level processing or noise removal. If you give any noisy image, after processing, you are going to get the noiseless image. And image sharpening. That means if you are giving any noisy image, that particular image can be enhanced. Image can be sharpened. Coming to the second type of image, that is digital image processing type, it is mid-level processing. So in this mid-level processing, the input will be image and output will be attributes. So input will be image and output will be attributes. That means for this type of processing, for the machine, if you are going to give image as the input, you are going to get attributes as the output. Generally, what are different attributes that the machine can be collected from the image means it may be pattern, it may be texture of the image, or it may be regions of that image, or it may be color of that image, size of that image. So all these comes under attributes of the image: texture, pattern, regions, color. All these will be extracted at the output. And the third level of processing is high level processing. So in this high level processing, input will be attributes and output will be understanding. So input will be attributes and output will be understanding. That means here the whatever the attributes, like for example, if you are going to give some image attributes like color, shape, size, or texture, or region, the machine, after processing that particular attributes, it is going to understand and tell, it is going to recognize that particular object. What type of object it is, either it is ball or either it is any vegetable or any fruit. Okay, what is the scene where it has been captured. So like that, it is going to recognize and classify. So some of the examples that comes under this high level processing is scene understanding, and this can also be used in navigation purpose. So these are three different types of digital image processing. And methods used for image processing. So generally, two methods will be used. One is analog image processing and another one is digital image processing. So generally, the basic difference between these two types of processing are, so in analog processing, generally electrical signals it is going to consider and it is going to operate based on the electrical signals. And in digital image processing, it is going to operate based on the machines. So here, analog image processing means, in this type of processing, images will be manipulated with the help of electrical means by using electrical signals. Whereas, if you see television image, all that particular images comes under analog image processing. And next type is digital image processing. So in this type of processing, images are manipulated with the help of computers, machines. This is the basic difference between these two. So in analog image processing, image will be manipulated with the help of electrical signals, whereas in digital image processing, images will be manipulated with the help of computers. So these are the basic steps during digital image processing. So the basic steps are, first we have to go for image should be pre-processed. Next, the pre-processed image should be enhanced and displayed. And the last one is, from that enhanced image, the information will be, important information will be extracted. So these are the three basic steps the image will undergo during this digital image processing process. And next, after learning all these, we have to know what are the advantages and limitations of digital image processing. So here are some of the advantages and limitations. So coming to advantages, the first advantage is improved image quality. So in the computer, we are going to apply different efficient and sophisticated algorithms in order to process the image, and that particular algorithms will make the improvement in the quality of the image, so that the image will get enhanced and the quality of the image will be improved and image will get sharpened. And next advantage is automated image based tasks. So like object recognition, pattern recognition, and calculation of different attributes, all the things will be done automatically without any human intervention. So as it is done automatically by the computer, the speed of operation also will be increased. And the next advantage is increased efficiency. So increased efficiency means, as all the operations are done automatically, the speed of operation will be high. The computer can perform sophisticated algorithms in short span of time. So the efficiency will be increased because the algorithms will work more faster compared to the human. So in this way, the efficiency will be increased. And the next one is increased accuracy. So this digital image processing algorithms, whatever it is applied on the image, that particular algorithms will work accurately compared to human. And this particular algorithms will be giving more accurate results. So these are the advantages of digital image processing. Next, coming to the limitations of digital image processing, there are also some limitations like high computational cost. So we need to have computational resources because you need to perform more sophisticated algorithms which are very complicated. So in order to process that, the resources also should be strong. And next limitation is limited interpretability. That means here the computer, after performing the operations, it is going to give some results, but we have to check whether that result is correct or not. And as it is applying more sophisticated algorithms, it is going to give some results. For the human, in order to calculate all that results after getting the output, it is taking more amount of time. And if we accept the output, whatever the computer is going to give, and we are not sure whether that output is correct or not. So that is what limited interpretability. We are not able to analyze whether that extracted output is correct or not. It will take more amount of time. And the next one is dependence on quality of input. That means for the computer, whatever the input you are going to give, that particular input should be quality input. Then only after performing the algorithms, the output also, whatever we are going to get, the output will be improved. So if the input is good, output also will be good. If the input is poor, applied input is poor, the output also will be poor. So it is completely dependent on the quality of input what we are giving. And here, limitations of algorithms. So some limitations like it is not able, some algorithms are not capable of recognizing the objects correctly. And so dependence on good training data. So these algorithms also depends on training that particular algorithms. If that algorithms are trained properly with the good quality data, then only it is going to produce the output correctly. So if the input to test that, to train that particular model, if the training data is not good, that particular, even though if you apply the algorithm, it is not going to give proper output. So we have to see that poor quality training data results in poor performance of the system. So we have to see that it should be trained properly and that training data should be well and qualified. So these are some of the limitations of digital image processing. And so the content here, whatever we have discussed, some of the content we have been taken from the textbook Digital Image Processing by Rafael C. Gonzalez, second edition, 2005. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.